In this video, we will be reviewing finding slope from 2 points, as well as developing a better understanding of the meaning of slope and being able to interpret it in terms of a real-life situation. Here we're going to practice calculating slope from 2 points. An important thing to remember is the equation for slope, which is our y2 minus y1 over x2 minus x1. I always recommend writing this equation down when we're working with slope so that it's easier to substitute our values and stay organized. Okay, so that's the equation that we're going to use. Now I'm going to go ahead and label each of the values. So we'll start with the first one, -3, -2, and 3, 1. So this is finding the slope of a line that passes through these 2 points. So I'm going to label this as x1, y1, x2, y2. Now when I look at the equation for m, I find where my y2 goes, which is right here in the numerator. My y2 is 1. So I have 1 minus y1. Well, y1 is -2, so I'm putting a parentheses -2. That parentheses is very important to make sure that you incorporate both of those negatives because you do have a sign change. And then we're going to do x2, which is the 3, minus, again, parentheses, -3. So the negatives in the numerator become positive and I get 3. The negatives in the denominator also become positive and I get 6. And then I need to remember to fully reduce, so I get 1 over 2. And that is my slope. And another reminder, 1 is your rise and 2 is your run. All right, let's go ahead and do the next pair. -5, 2 and 5, 4. So once again, I'm going to label my values, x1, y1, x2, y2. And now I once again plug it into the equation for m, and I have y2, which is -4, minus y1, which is 2, all over x2 minus x1. Okay, so -4 or -4 minus 2 is -6 over, these two negatives become a positive, so -6 over 10. And then again, we need to remember to fully reduce, and we get -3 over 5. All right, the next pair, we have 1, -5, and then 5, 5. So once again, I'm going to label x1, y1, x2, y2. Now, go ahead and pause the video, and I want you to go ahead and try calculating the slope using these points and seeing what you get, and then go ahead and restart the video and follow the steps and see, check your answer, check your steps and then check your answer. All right, so assuming that you've already tried it, I'm going to go ahead and work through it. So I have y2, which is 5, minus -5 over 5, that's my x2, minus 1. I have 2 negatives, which make a positive. So I have 10 over 5 minus 1, which is 4. Divide by 2, and I get 5 over 2. So that is my slope. And again, 5 is my rise, and 2 is my run. All right, go ahead and try the 2, -5, as well as the 1, 4, and calculate the slope. So pause the video and try it, and I will go ahead and take you through it. All right, the first thing I'm going to do is label my coordinates. So I have x1, y1, x2, y2, and my y2, which is 4, minus my y1, which is negative 5, all over my x2, which is 1, minus 2, which is my x1. All right, once again, I have negatives that are right next to each other, so those turn positive. So 4 plus 5 is 9, over 1 minus 2, which is negative 1. So you can write the slope either as 9 over negative 1, or you can write it as negative 9 over 1. Both of those will result in the same line. And again, the rise is negative 9, and the run is 1. For each of the problems that we're going to do next, we have 4 things that we're going to do. A is to identify at least 2 ordered pairs from the graph. B is calculate the slope of the line. C is write the units of the slope. And D is write a sentence to interpret the slope in the context of the problem. Be sure to include units. So number 1 says the graph below shows the population of a town over a period of years. Let x equal 0 represent the year 1980. Let y represent the town's population x years after 1980. So x equals 0 represents 1980, x equals 1 represents 1981, x equals 2 represents 1982, and so on. All right, so the first thing I always need to do is figure out what the important information is within this. And I'm just going to go ahead and underline that. And then we're going to go back to our A, B, C, and D activities and go ahead and take care of those. Okay, so the graph below shows the population of a town over a period of years. So here I see the term population, and I also see the term years. So this graph is representing a population, so number of people over a certain number of years. Okay, we have let x equal 0 represent the year 1980. So that is basically stating that all of our measurements are beginning in 1980. Begin in 1980. Okay, let y represent the town's population x years after 1980. Okay, so another thing that I can do here is it says let y represent the town's population. So a population is really a number of people. So for dealing with units and things like that, we want to actually say what that population is. Well, it's a population of people, and that's y, so it's on our y-axis. All right, the other part is number of years. That's x. So our x-axis I'm going to label as years. Okay, so that's the information that I've pulled so far from the written content. Okay, so part A says identify at least 2 ordered pairs from the graph. All right, whenever we're looking for ordered pairs, we are looking for something in this form where we have an x and we have a y. Now in this case, they want 2 ordered pairs, so I need to come up with 2 x's and y's. All right, now for me, the easiest ones to see are the ones that they have colored in here in red. So I'm going to figure out what my x value is. I'll switch to white here. So my x value, I haven't moved anywhere horizontally, so my x is 0. And then my y is where that arrow is, and that's 20,000. And notice that is my y-intercept because x is equal to 0. All right. So now I'm going to look for a second point. Well, I see I have another point here that's fairly nice because it looks to be on whole numbers. So here I've moved over to x of 20. So I have 20, comma, and then how far up are we? We are at 19,000. Okay, so those are basically the answers to part A. Those are the at least 2 ordered pairs from the graph. All right, now B is calculate the slope of the line. Well, just as a reminder, the slope is y2 minus y1 over x2 minus x1. Well, since we've identified 2 points, we have an x1, y1, and x2, y2. So I'm going to label those. So I'm putting the first point as 0, 20,000. So x1, y1, x2, y2. All right, now I need to plug those in to find the slope. So I have y2, which is 19,000. That's y2 minus y1. That's that one. Over x2, which is 20, minus x1, which is 0. Okay, so 19,000 minus 20,000 is negative 1,000 over 20 minus 0 is 20. Remember to always fully reduce your slope, so those zeros can cancel. So negative 100 over 2 is negative 50 over 1. And that is our slope. That's the answer to part B. All right, so write the units of the slope. Well, the units are what we take from the axes, from the x and the y axes. Now the rise is always the top part of the fraction. That's the rise, or our y. And then the bottom is always the run, or our x. Okay, so I'm going to figure out what the units are for our y-axis, which in this case I labeled earlier as people. So we have people on the top over the unit on the x-axis, which is years. So that would be people per years or per year, depending upon how far down we reduce our answers. Okay, so that's part C. Those are the units. Now D is write a sentence to interpret the slope in the context of the problem. Be sure to include units. Okay, the very first thing I'm going to do here is write my slope, the negative 50 over 1. But this time I'm going to include the units that I identified in part C. So this is saying that the number of people in the population is decreasing by 50 people per year. Now, it's decreased because there's a negative there. So I would always place the sign in the top. Whatever your y-axis unit is, that's where I would put my negative. So now we need to write this as a sentence. So the slope means that the population is decreasing. And again, the decreasing comes from that negative on the 50. So the slope means that the population is decreasing by 50 people. Notice I've included the units for our y-axis, by 50 people per year, or per 1 year, which notice corresponds to what's on the bottom of the slope. And that is the interpretation of the slope written out as a sentence. In this problem, we'll be doing the same thing as we did in the first problem. First, we're going to identify at least 2 ordered pairs from the graph, calculate the slope of the line, write the units of the slope, and then write a sentence to interpret the slope in the context of the problem. And a reminder to be sure to include units. All right, so for part A, we need to identify at least 2 points from the graph. So looking here, I see that we have a y-intercept, and we also appear to have an x-intercept. So I'm going to pick those 2 points. Now, as long as you pick 2 points that actually fall on that line, then it doesn't matter which points you pick. I just like to pick ones that are a little less complex to calculate, and usually the intercepts fit that bill. Okay, so I need to figure out what the coordinates actually are for these. So I haven't moved anywhere horizontally, so I have 0, and that looks like 200. Okay, now we have moved over to 60 on the x-axis, and we haven't moved anywhere vertically, so that's at 0. Okay, so I'm done with part A. Now it says calculate the slope of the line. All right, so just as a reminder, our slope is y2 minus y1 over x2 minus x1. All right, just to keep myself organized, I'm going to go ahead and write the coordinates that I found in part A, and that way I can go ahead and label them with my x1, y1, and so forth. Okay, so I'm going to put my first point as x1, y1, and then I have x2, y2. All right, so now I need to insert into the slope equation. So y2 is 0, minus y1 is 200, x2 is 60, minus x1, which is 0. All right, so the top, I get negative 200 over 60 minus 0 is 60. So my zeros can go away, and now I need to see if there's any other common factors. So notice I'm always fully reducing my slope. Well, 2 goes into both negative 20 and 6. So 2 goes into negative 20, negative 10 times, and 2 goes into 6 3 times. So my slope, or the answer for part B, is negative 10 over 3. All right, so I went ahead and did that. Now part C, we want to identify units. So this says the graph to the left shows the height of a hot air balloon as it descends. Let y represent the height. So here we have height on our y-axis. So I'm going to go ahead and label that. So I have height. And again, that's on our y. And it's measured in meters. So let y represent the height of the balloon above the ground in meters. So meters. All right, that's my y. And let x, so x, represent the number of minutes that have passed during the descent. So our x equals minutes. Okay, so going back to our slope equation where we have our y on top, that means that our height is going to be in the numerator, or the unit for our height is going to be in the numerator, and then the unit for x, for our minutes or our time, is going to be in the bottom. So our units are meters per minute, or minutes. I'll just put parentheses there because you may or may not have that x, or the s. Okay, so I've now identified the units for the slope, and now I need to write a sentence. So I put all of these things together. And again, we're dealing with a hot air balloon that's descending, so it's going down. Now, something to note here is we knew it was supposed to be descending, and notice I have a negative on my slope, so that's confirmation that I've done something right, because that slope should be negative since the balloon is descending or going down. Okay, so the sentence for this, again, we use our units. So we have the height of a balloon is decreasing, right, because we have the negative, is decreasing by -10 meters per 3 minutes. So what I'm going to do is rewrite the slope like I did in the last problem, including the units. So I have -10 on the top for the slope, and it's meters, which goes that comes from the units in part C. And then I have 3, which is the slope, and then the minutes, which comes from the units in part C. All right, so now I'm going to actually write out my sentence. So the height of the balloon is decreasing by 10 meters. You can say per, so per or every, that sounds a little bit better to me for this, in this case, by 10 meters every 3 minutes. So notice I've included the number from the slope and the unit, and then for the other part, the x, I also have the number and the unit. So you need to make sure to include what is changing, the direction in which it's changing, and then also the amount and the units for each direction. So 10 meters every 3 minutes. All right, so I'm going to go ahead and pause the video, and I would like you to pause the video and try the next problem on your own, and then restart the video and try watching and seeing if what you've done is correct. Okay, I'm assuming that you've already tried this problem and now you're just watching to see how you did, and make sure to pause it if you see any mistakes so you can correct them in your work and then restart. All right, so just like in the previous problems, we're identifying at least 2 ordered pairs from the graph. We're calculating the slope of the line, writing the units of the slope, and then writing a sentence to interpret the slope in the context of the problem. All right, so I'm going to read the text from number 4, and it says the graph to the left shows the amount of water remaining in a pool X minutes after an electrical pump is started. So I'm highlighting the important information. So we have that one measurement is X minutes. What happened was that an electric pump was started. All of those things will be important when we're writing our sentence in part D. And then let Y be the amount of water. So amount of water in the pool in gallons. Again, everything that I have marked will be included in some form or another in the sentence that we're going to write. Okay, so part A says identify at least 2 ordered pairs from the graph. Well, they've actually given us 2 points, so that's nice. So we already have A taken care of. So A is 10, 4,200. And the other one is 120, 900. All right, so I'm done with part A. Now I need to move to part B, which says calculate the slope of the line. So I know that I need to write out my slope equation, y2 minus y1 over x2 minus x1. I am also going to label my points. Okay, and now I'm going to put those values into the slope equation that I wrote in B. So y2 is 900 minus y1 is 4,200 over 120 minus 10. Okay, so now I get that 900 minus 4,200 is negative 3,300 over 120 minus 10 is 110. I always need to reduce as far as I can. So these 10s go away. And now I need to see if 11 goes into negative 330, which it does. It goes in negative 30 times. So that becomes negative 30, and the 11 goes away. So it's negative 30 over 1 for my slope. Okay, so I just figured out part B. Now I need to go to part C, which is writing the units. Well, I've already pulled out important information from the words that I have up here. And I also have units included on the graph, so we didn't even have to label that, which is kind of nice. But notice that our y-axis, which is the unit that always goes on the top for the slope, is gallons. And the part on the bottom, the x unit, is minutes. Okay, now just in the previous problems, I'm going to combine the slope with the units. So I get negative 30 gallons over 1 minute. So now I need to write my sentence. Okay, so again, going back to the important information I included, or I marked in here, we have an electric pump that started. We have an amount of water remaining in the pool based on X minutes after the electric pump was started. And then the amount or the unit of water that we're measuring is gallons. So my sentence is going to be something like, let's see. So how about the amount in the pool is decreasing by 30 gallons every 1 minute after the pump is started. All right, now don't forget, you have decreasing, which is because of the negative on the slope. So if it were a positive slope, you would be increasing. 30 gallons is the quantity in your slope, and gallons is the unit. That's for your y. And then every 1, in this case, that's the slope for your run, the denominator of your slope, and minute is the unit for the denominator of the slope. And that is the completion of part B. And we had completed part C before we did that as well.